definitely trickle. We know Tom trickles when he...
Well, welcome to our October method seminar. So today we're very fortunate to have one of our own who's been with us for over 10 years now.
I think so, at least. Yeah.
So he'll be presenting very exciting stuff, analyzing sexual behavior from the Healthy Living Project. So welcome, Dr. Weiss.
Okay, so this is joint work partially with a lot of the people in the room back in the day, and then the other half of this is with, maybe more than half, is with a student of mine, Yuta Zhu, who's now up at Genentech and did the other analysis. So Healthy Living Project was a major grant here in the center, and it was an intervention, a behavioral intervention for people living with HIV. And the study objective was to evaluate whether a counseling intervention, how it affected the behaviors of the HIV positive participants in the study over time. And one of the big, huge negotiations that went on while the study was going on was what was the primary endpoint. Those are things I think are supposed to be decided beforehand, and whatever it had been decided, it eventually came around and ended up back at the same place it started, but it was under negotiation. But the quotes mean this is from the paper. So the paper author is team, THLP, which is when I was entering the trying to look for the paper and entering it in Google Scholar, Google recognized that it was a last name with 4 first names and abbreviated them that way. But THLP is the Healthy Living Project team, is the actual author of the paper. So primary endpoint was transmission risk acts, which was number of unprotected sex acts during the last 3 months with partners whose HIV status was negative or unknown to the participant. So how can, one of the things to think about is, sign me up, would you, Jay?
Okay.
Thanks. It'd be bad if I didn't go to my own talk. So one of the things to think about, though, is how can a counseling intervention, or any intervention, change sexual behavior? So it can do this in a bunch of different ways, and it's important to think about these. So the forming of new relationships, that's a subject level behavior, if you like. So the number of partners and the serostatus of partners. Then there's behavior in the relationship, that's partner level, so participant-partner combination. There's the number of sex acts, there's protection, condom use, and there can be behavioral differences based on partner serostatus. That gets us into serosorting, and that'll kind of be, if you guys don't talk and I rattle on rapidly, then we'll be talking a lot about that at the end. If things go quickly, if things go slowly, then I'm very happy because that meant we had a good discussion. So you're welcome to chime in here. Some of the people here were major participants in some of this, so they'll have a lot of background knowledge.
So Rob,
yeah.
can you remind us what the sites were, the locations?
So there were four sites to the study. There were, seems to me, Baltimore, LA, San Francisco, and Milwaukee. Yeah. And the purpose of Yuta and my reanalysis of the data was an accurate transmission risk model. So the first analysis, and this is the first, not the first publication out of the grant, but major one, Healthy Living Project team in JAIDS. Took us a while to get it in there. We bounced around a few journals, and maybe that's inside baseball. I'm not supposed to tell, but I see why we should hide that from people. This reanalysis is part of Yuta's dissertation, and that showed up in biometrics. So that was kind of taking care of all of the issues that we wanted to take. I don't know about we, but I wanted to take care of in the earlier part that we weren't able to for. So there's two analyses, and I'm kind of contrasting these two in a bit. The one that we published, and I was a major participant in this, so I don't want to make this look like somebody else did this and did this wrong. I was in there. I spent about my entire allotment from CHIPTS, whatever they were paying for, and maybe more per week over a year. And Lenny Wong, who was doing the major analysis, was probably putting in half-time, or she was being paid half-time, but she was putting probably in full-time, trying to get this thing done. So there was a lot of effort, and then there were a zillion other people who were thinking about it very hard and contributing. I don't want to say nitpicking, because that's not what was going on. There's a lot of people talking back and forth about how to get this analyzed right. So it was a univariate longitudinal analysis. The outcome was transmission risk behaviors. In other words, it was a total counts of unprotected acts with their HIV negative or unknown partners. We used a Poisson model for counts and a random intercept covariance model. The covariates were time treatment and the treatment by time interaction, and more or less that's the interaction is the question of whether is there a significant difference between the two groups. One of the problems we ran into was that there was a imbalance between treatment and control in this outcome at baseline, and so that was a cause of enormous discussion, and because of that we ran a propensity score analysis, which basically is a way of stratifying at baseline into subgroups and analyzing the subgroups. The subgroups are cut across treatment and control. So you're doing a treatment control comparison within the subgroups that are hopefully similar, and then you combine the subgroup analyses into one overall analysis. And so getting all of this worked out and run, and it was quite a chore. There was a lot of work and effort. So a picture of that. Here's a subject, and the subject has baseline data. There were 5 follow-ups every 5 months. I still find that kind of amusing. But 5 times 5 is 25, which is only 1 month off from 2 years, 24 months. So it's actually a sensible amount of time. So there's follow-up 1 through 5. And the picture is these blue means HIV negative unknown partners, and then line through it circle means unprotected acts. So there are 3 unprotected acts with HIV negative or unknown partners. And because of the way the study was designed, we'd ask about the first 5 partners in detail, but then after 5, we just asked global information. So how many partners, how many acts, how much was protected. And so we had to do some imputation there to fill in the details of whether those acts were with protected or unprotected partners who were unprotected or were HIV negative or unknown. Something like that. I threw the right words in there. I'm not sure that was a sentence, but okay, so, but anyway, univariate analysis, 936 people. When we came around to reanalyzing this, Yuta and I, it's a multivariate longitudinal analysis. So that means there's more than one outcome at each time point assessed over time. And we split everything up and included everything that we thought was important, really. So we split up partners. There's a count of HIV positive partners, and there's the count of HIV negative partners. So that's 2 outcomes. And then because it's 6 time points, baseline plus 5 follow-ups, then repeated 6 times. Then on each partner, we have acts that were either protected or the count of unprotected acts. So for the first 5 partners, they were actually asked this information, so we have it directly. If there's more than 5 partners, again, we also had to do imputation to fill in those things. And then when the partner is HIV negative, and I'm abbreviating, that's HIV negative or unknown. So I'm not going to keep repeating that, so just HIV negative does mean unknown HIV status. And we also have the protected acts for if they're HIV negative partners and they're unprotected acts. So those are treated as 6 outcomes per person. These last 4 are nested within partner. So these are not aggregate over all partners. These are nested within partner. In terms of the covariance modeling, I'm not even going to tell you everything about that. Partly it's a lot of nitty-gritty, and partly other things I want to talk about instead.
So the partner stuff, that's self-reported, right?
Everything is self-report. You could attach self-report in front of the whole study, the title, this, yes,
And then
definitely.
did you have enough partner level data to see if the HIV negative partner across time seroconverted?
Don't know. Never was given that information. We don't have anything about we don't have partner matching over time.
So the first 5 partners you don't have?
I don't know if they were continuing on. So we'll be treating as if partners next time are independent of the current times.
Got it.
That's a negative that I don't have a solution for easily. So anyway, 2 counts that are totals, but then the rest of these are nested within partner. Random intercept model, except that it's really a autocorrelation model. It's not exactly the same over time, so it's allowed to bounce around. And that allows for over-dispersion to go on in there. One of the things we did, there's an entry, I'll talk about in a minute, there's a study entry criterion, and that actually requires that the people have risky behavior before entering the study. So we actually know something about the outcome before they even get in. And we didn't do anything with that, but it was definitely a cause of some issues, and I'll talk about that. This is a fully Bayesian analysis. We can come very close to specifying this model in some parts of SAS, but I wouldn't even bother trying to run it, because whenever I've run things that begin to look like this in SAS, it doesn't run. It's not that SAS isn't capable of specifying some of this stuff as a please fit this model, but it won't actually run when we say that. So running things in a Bayesian fashion means that I can fit models that I want to fit, not just models SAS wants to fit. And we did throw in, so one thing that makes it different from the previous analysis is we threw in a bunch of other covariates. So site, there's 4 sites. Risk groups, IDU is anybody whose IDU is in the IDU group. And then MSM, heterosexual male and females are the other 3 groups, but are not IDU. Race, so black, white, Hispanic, and other. Education, age is an indicator greater than 40, working, yes, no, and I think drug use is a yes, no type variable. And we did we also did a careful analysis of serosorting, so that's something on top of the main analysis, which would be just, is there an intervention effect? Okay, so the picture looks like this. It's a much more complicated picture. There still are 936 subjects. Subjects still have baseline and a whole bunch of follow-ups. But now what we do is each partner is HIV positive, if they're red, or blue is HIV negative unknown. And then within each partner, there are protected acts 6 and unprotected act 1, protected acts 3, no unprotected acts, and so on throughout. And so we're actually modeling data at this picture is actually what we're modeling in this. We call this a sexual behavior profile. And so we're not aggregating at the act level. And we also have partners in there multivariately. So it's a fairly complicated, that's one person's one-time data plus all those covariates. Now, the first 5 partners we get a lot of information about. So partners F, G, and H, we don't actually have that. And so if we did have 8 partners, then we would be imputing these counts in here. And one of the things we're doing in this analysis is actually the counts bounce back and forth because we don't know exactly what they are. They're random. They're not completely known. There's some constraints given what people told us, though, on them. So some of the benefits of this, this a cute phrase up here, which is hard to parse, disaggregation on a per partner basis is what I was just explaining. we can distinguish many partners with one act per partner versus one partner with many acts with that partner. Those two come out very differently in our analysis, potentially, compared to the aggregate analysis when we're aggregating acts within HIV-negative partners, across all HIV-negative partners. One of the things this gets is it gets models the sources of variation in the data correctly. So when we add up, if one person has 5 HIV-negative partners, then acts are nested within those partners, and there's some discussion with each of those individual partners, and we have individual partner random effects in our model. And so then that's got different variability than if there was one person and it may be still HIV negative, but many acts within that person. And the variability will be different in those two situations. And so that was one of the things we were able to do, and that was one of my original goals in doing all of this. We can also handle seroadaptation. We can quantify behavior differences. For example, comparing HIV positive and negative partner behaviors, the behaviors with those partners and how they're different. And then another important thing is the eligibility criterion. We can directly incorporate the eligibility criterion into our baseline distributions. But before we get to analyzing things, we got to randomize. And when we randomized, so the quote is from the first paper, the 2007 publication in JAIDS. Although participants were randomized, comparison of transmission risk acts at baseline revealed an imbalance between the intervention and control groups. And so this is for mean number of unprotected sex acts last 3 months. P-value comes out at 0.009, mean difference intervention 20, control average of 13. And boy, we chewed that bone for months trying to figure out if we could make some excuse and not declare significance, and we really couldn't get around it. We tried a lot of different things. Now that's unprotected sex acts total, not with HIV negative or unknown partners, but it's still P.045, so borderline significant for the outcome that we're interested in. Yeah.
Was the randomization to the intervention control group done after the baseline assessment?
I think it was like right after. Initially it was going to be, I guess there was some delay, but after quick change it was done right after the initial assessment.
So people were blind to their intervention condition before, while doing the baseline assessment?
I think that was always true.
That was always true.
We did try to go back, and I remember there were supposedly calls back to the coordinators in the different local sites trying to see if there could have been some, but nothing. Yeah, but.
Well, so one thing I remember too is there were supposed to be different strata,
Mm-hmm.
but that didn't actually happen. So I remember Lenny gave a whole presentation on that, and they were going to stratify on, gender and different ethnic groups, but somehow that didn't get incorporated
into the randomization.
The randomization scheme. And so they ended up with some really big imbalances on some of those characteristics.
Okay, thanks.
And weren't there some, I remember, site variations across
The sites are very different.
right?
The races are very different, and the risk groups are very different. And now take an interaction between those. I haven't even gotten to that analysis yet,
Right,
but
so
send a few bucks my way, and we'll be right on it. Honest, I'm very interested in that, but don't get me started, or we'll never get out of here. I'll lock the door. So eligibility, you had to be risky. Well, what are we doing? We're assessing risk and whether it's changed over time and in between the two groups. You were eligible if you had at least one act of unprotected vaginal or anal intercourse previous 3 months with an HIV negative or unknown status. And now here's the fun part. Or you were eligible if you had unprotected intercourse with somebody who was HIV positive but wasn't your primary main partner. So that's a little bit more complicated, but in our analysis we do have both of those as outcomes. And so what this says, let's forget about the second one, but it's just more complicated algebra, but the ideas are the same. So just the first one, it's saying that you can't have a 0 in some partner who's HIV negative. You can't have a 0 count of unprotected sex in that cell someplace. So back in our picture here, one of these, blue, unknown, has to have an unprotected act or you weren't going to get into the study. Now it's a little more complicated, but it's, so we actually adjusted for that. We actually included that in the distributional specifications of our modeling. So it didn't occur to me, I don't think, at the time, or we could have discussed it. I don't remember it being discussed, but we didn't include that in the enrollment, in the analysis. I'm not sure if we could have or not. It would have been hard. But we definitely noticed a huge drop between baseline and the first follow-up. And that also sent us into a big, huge set of discussions, and we were discussing this at length. To the point, I know Naiwa has presented something at one of these method seminars a long time ago. He's much quicker than I am, about that drop and what could possibly cause it. And I'll talk about some hypotheses. I'm not going to give you, I thought I had the answer for you. I advertised to people that I had the answer for that, but I'll just give you some hypotheses in a minute. So on that eligibility criterion, we analyzed it, either 0, well, I guess I kind of said that. We have main partner as a covariate predicting acts, so we can actually get that distributional thing in there as well. We notice lesser of a drop after baseline, partly because we're modeling acts per person, not total acts. And I do have a picture of total acts, so you get to see what that actually looks like in our analysis. And so we can, though, add or model and total number of acts per person, and so we can plot total number of acts over time from our fitting as opposed to from the raw data. But when we do that, we're going to allow 0 outcomes at baseline, so that kind of brings what a typical person is doing at baseline back into line with the other time points, so that there's more comparability there between baseline and follow-up. So this is just cut and paste straight from the publication of the first paper. Intervention effects are significant. Here's raw data. I don't remember what we did, but we managed to get our fitted lines to look like the raw data. That's often kind of hard in Poisson models, actually. And I have potentially someday another paper on that subject, but that's not done yet. And you can see the difference between the two groups. Here's the fitted value. It's kind of manfully trying to get up there, but not quite making it. But at the other time points, fitted and observed aren't too far off. And the result was that not much difference at 5 months, but at 10, 15, and 20 months, we are seeing a significant difference between them, and lower numbers of acts in the intervention group, the solid line instead of dotted line.
And then at 25 months, they were
Back,
pretty much the same.
yeah.
What
Now,
did the intervention end?
the intervention was going on, I believe, in 3 chunks, starting after baseline, another chunk between, and another chunk, but I might be wrong on that.
So they had about 10 months with no intervention for the
Yeah,
for that final follow-up.
right. This is our analysis. So remember, we had 6 outcomes. So there's small print, 6 outcomes and 6 plots. Left column is HIV positive, right column is HIV negative, partners on top. You'll see there's a small decrease in number of partners over time. Should be, I think we kept, because of the randomization, they should be equal, so we modeled them as equal at baseline. Otherwise, I can't understand why I only have 1 bar at time 0. But different you can see the 2 confidence intervals at the follow-up times. Decrease, seem somewhat bigger decrease in the number of partners over time. These are mean numbers. The second row HIV is ACTs per partner, HIV positive partner, HIV negative partner over time. These are protected. This bottom row is unprotected. So the thing that's really of interest is that this should go down and hopefully be different in the treatment group. We found no differences between treatment and control at any time points, adjusted or unadjusted. So there's 6 outcomes here, no differences between treatment and control. So in our first analysis, we did find significant differences at 10, 15, 20 months. We didn't find them at any, we also didn't find them, by the way, at baseline, which is kind of interesting. So when we were doing that. Our graphs are, in particular, we had a lot of covariates in there. So we picked one covariate value. White MSM, less than 40 years, from LA site. Did not graduate high school, were out of work, and no history of hard drug use. So we can look at all of those covariates. I'm not going to show you every covariate, though. One thing about our analysis is we did have a lot of results. One model, very large, a lot of results. Really, you could write couple papers, applied papers, out of that one analysis. And if analyses go like I would prefer to have them go, which are all-encompassing, then that could very well be the case where we have 2, 3, 4 papers coming out of one single actual model fit, not even counting things like sensitivity analyses and stuff like that. This is time trends and group effects. So this is the solid line MSM. There's 2 dashed lines, which makes it hard. Females are smaller dashes, IDU bigger dashes. This is not all 6 outcomes. This is, but this is totals. So this is total number of partners and total number of HIV negative partners on the right. This is total unprotected sex acts. I'm forgetting about the protected one. I'm not reporting the number of protected ones. And unprotected sex acts with HIV negative. So the right-hand column is a subset of the left-hand column. Number of partners, so 2, 4, 6, and I'm not giving you uncertainty values. Decreasing over time. Negative partners decreasing over time in all groups. Unprotected sex acts, total number decreasing, and with HIV negatives definitely decreasing, although it levels off there. MSM have slightly the largest number of partners and HIV negative partners. Total unprotected sex acts, this I believe is, looks like IDU, doesn't it? IDUs. I was thinking it was females for some reason. This one I believe is females though. That's not the same dash as that dash. So, so females, one of the things that kind of came up was females had more HIV negative partners and people from Milwaukee. And so a description of what was just shown. All right, so this is the discussion of that decrease, okay? So I'm going to throw out 4 or 5 hypotheses here. So one of them, population temporal trend, I don't think anybody ever advocated that as a possible thing, but if the population was decreasing their amount of risk, that would explain this nicely, but unfortunately nobody really believed that. Naiwa was promoting one that he called survey conditioning, which is that when you take the survey, if the survey kicks you, you're going to tend not to respond that way the next time around. And so that negative feedback in the survey, which would happen if you said, oh yes, I had one more partner, and then boom, you're asked a whole lot of questions about that next partner. So that would be negative feedback and might encourage people to not mention their next partner. So they don't have to report so much at later surveys. If that's the case, then the decrease over time is artificial and it's due to respondents gaming the system. One that I've been willing to advocate, and advocate doesn't mean stating this is correct and this is the explanation, but advocate as a possible mechanism, is the survey as intervention. And I'm sure I'm not, I haven't bothered to look it up, but I couldn't possibly be the only person who said this before. So the survey is an intervention, and perhaps people don't realize just how much risky behavior they're doing, and so they're getting feedback via the survey, and so then the decrease is real under that hypothesis, but the cause is not the intervention, the cause is just the survey. Now, related to that, almost the same thing, is just being in the study, and study participation isn't the same as taking the survey. Taking the survey is part of being in the study, but it's not the same thing. So that's a kind of variant alternative on that. Something I came across, and the reference is down here, Torengo, Rips, and Rasinski. Great book, Psychology of Survey Response. Highly recommend it. Very easy read and fun. So that decrease is in both groups, not just treatment, but both treatment and control. And so a possibility that they discuss, they're not claiming that it's happening, but they're throwing it out there. It has a name, forward telescoping. And I'm the one saying at the first interview, so at that baseline interview. Forward telescoping would mean that basically they're reporting on more than 3 months worth of activity. So it could be that they aren't quite sure where that time ends, and so they're bringing in extra events in there. Also, if you think about, like, if that was random, how much time some people might report short, some report long. And if you think of it as a multiplicative effect, like some people might report on 2/3, but others are going to report on 3/2. So those two balance out multiplicatively, but that means one person's bringing in a lot more than the other person's leaving out. And another thing going on related to that would be temporal compression, which is thinking that events are more recent than they actually are. There's occasional studies on these kind of things when we have separate documentation about the events, crime, for example. And the reference inside the book, section 4.32, if you'd like to follow up. And then along with this, I'm proposing that participants would actually landmark. They're being asked about the 3 months, and actually one of the clever things about the survey, it wasn't every 3 months, it was every 5 months. So this is suddenly a plus that people come in like 4 months, 5 months, 6 months. Well, if they're coming in 2, 3, 4 months apart, and you're asking the last 3 months, there can be overlap, and you definitely don't want that. So that was actually a good thing in the study, but still they know they're going to be asked about the last 3 months, so suddenly now they're a little more careful about when is 3 months actually going to occur, and they're better able to estimate back to exactly 3 months, so they're not doing the same forward telescoping or temporal compression that they might have been doing before. So that's a proposal. Now another thing is the entrance requirements. I thought this was covering all of it, but that's not correct. That's just but it does cover some. Since you have to have some risky sex at baseline, then at the follow-ups they can have 0, and so 0 is possibility. The means are going to be lower. And an example, the classic example that is blood pressure study. So why do we have control groups in the first place? Well, if you go if you're doing a blood pressure study and you're just going to take people in, oh, you've got high blood pressure, okay, bring you into the study, give you the blood pressure medicine, and then come back in a month and we'll measure your blood pressure again. Blood pressure readings are really noisy, guess what? So is sexual behavior things. Sampling variance is about double the population variance. And so that means that most high blood pressure readings are accidental. They're there because of just random things. Running up the stairs, nervous at the doctor's office, whatnot. And so basically you're guaranteed to have a decrease in blood pressure at follow-up. That's why we have control groups, because it's not due to the drug. You need the drug and you need the control group to compare it to see if they're both going down the same or not. Now there is going to be a little bit difference if you're selecting people who have one high blood pressure reading, because you're going to miss out on all the people that have no ever high blood pressure readings. So you're going to have slightly elevated blood pressure over the population if you select people this way, but not very much. Sometimes this is called regression to the mean, and we modeled that explicitly in ours. So in those pictures there's less of a decrease over time because of us getting that into the modeling. There still was a pretty big decrease, though, I think. So, all right, those are hypotheses. I don't have a way of decomposing the data and telling you which one actually was the right answer, though. So that was kind of the charge when I got, well, I won't use that verb, when I was requested to give this talk. So I wanted to put out that discussion. One of the things, though, is that those study entry, going back to the study entry things, if you're going to analyze those and assess how stuff decreased over time, you need to model that study entry criterion explicitly in the analysis at the beginning. Now, other outcomes aren't the study entry criterion, but they're correlated with them. So actually, in order to get them analyzed properly, we really need to be doing this multivariately and analyzing them jointly with the study entry criterion and doing a joint analysis and then allowing that correlation between the study entry criterion and the outcome you're actually interested in kind of filter across so that we can then do a better assessment of, like, for example, the decrease over time in these things. Okay. So last part on seroadaptation. And we realized that we had a lot of detail on this behavioral stuff, and we wanted to do more than just the treatment treatment effect analysis. And so we dug into the data and with this model, and this doesn't require any more fitting, but what it is that there are different outcomes that we can calculate because we've done things in this multivariate fashion. So seroadaptive behavior means using what you think you know about your partner to change your behavior. And I realized as I was writing this, you need to know your own serostatus too, or you're not going to be doing this right. And that's probably where a lot of transmission acts happen, when you think you're negative and you turn out you're not negative. And so it can be effective in form of risk reduction. It's not guaranteed. Your knowledge has to be correct. It is used to varying degrees, and so the analysis we have, we can actually assess what the seroadaptation is. And if people are trying to do something already, it's easier to do counseling to enhance something that people are already trying to do rather than trying to get them to change and really change what they're doing if they're just doing more of whatever it is. You still have STDs and other things that can pass on, but at least maybe fewer HIV infections. And a lot of the times you can't really assess a prevention study unless you're assessing the seroadaptive behaviors that maybe were created by that intervention. So seroadaptation can come in lots of different forms. You can have fewer HIV negative partners. This is, okay, our study is of HIV positive people. You can have fewer acts with those negative partners or with those negative partners compared to the number of acts you're having with HIV positive partners. You could have more frequent protection with those negative partners compared to what you're doing with your HIV positive partners. So another way of kind of saying this last one, a given protected act could be more likely to be occurring with an HIV negative partner. And we can kind of, because of the analysis we've done, we can kind of rebalance people. So even though if somebody's is having 75% of their partners are HIV negative or positive, we can rebalance that person as if they were doing 50-50 and comment on how much protection they're doing with their HIV negative partners. So we've actually taken seroadaptation here and split it into partners, acts with partners, and protection in kind of three semi-independent quantitations. And one of the arguments I'm making is that seroadaptation is relative. It's not it's not an absolute thing necessarily. So one person or one group of people can be more seroadapting than another group. Or the group of people you're following over time could be changing over time. One person could be behaving differently with their HIV negative and positive partners. And now when you get to zero partners, then we don't have seroadaptation. And so abstinence and seroadaptation are different things. Seroadaptation also can go in two directions. There can be good and bad seroadapting. And the problem is when you seroconvert, then what was good seroadapting behavior suddenly becomes bad. And that's probably where a lot of HIV infection comes in. And then if you understand how your population is already behaving, then you can do a much better job developing interventions. So here's a picture of our first one. This is partners. So here's two subjects, and we're comparing them. Red are HIV positive partners, and negative HIV, blue is HIV negative. So person has 2 and 3 versus person has 4 positive and 1 negative partner. So lower risk is happening at the partner level with the second subject because there's fewer HIV negative partners, and you can think of it as the fraction of HIV negative partners. So this table is an excerpt of results with lots of decimal points. The reference group is that long phrase I stuck a while back, but MSM, White, Los Angeles, and a few other things. And you can think of this 1.5 as an odds, not an odds ratio, which you're used to from logistic regression, but just an odds of whether that partner would be HIV negative or not. And then in the rest of the table, this is a reference group, and this is the major covariates, risk group, race, and location. These are the numbers are a multiple on top of this. So a number that's bigger than 1 means there's going to be more risk, more HIV negative partners. And so in particular, the females, the bolded ones, there's 2 of them, are the groups that are significantly more than the reference group. Women and, actually I'm not sure why that one's not bolded, but women and Milwaukee are 2 covariate groups that are having more HIV negative partners. I'm assuming that's because an HIV positive woman would have trouble finding an HIV positive man to have sex with, and it's much easier to find an HIV negative man to have sex with. And in Milwaukee, I'm assuming that there's just less HIV positive population, so it's harder to find an HIV positive person to have sex with if you would like to seroadapt in Milwaukee. So partners, this one is AX. So are you having more sex or less sex with your HIV negative partner compared to your positive one? Our 2 people, again, lower risk is below. We still have the same number of partners and same, which one? I have to go back 1 page. HIV positive is red, okay. So 2 HIV positive, 3 HIV negatives, but this should be moving the sex acts out from the HIV negative partners into the HIV positive partners, so less risk. And what happens here globally, greetings, sir, is that essentially, well, all of these numbers are less than 1. That's a good thing, meaning that acts tend to be more with the HIV positive partners than the negative partners. But none of these things are coming out as significant. There's one little exception that just basically barely snuck in there at 1, which is the IDU group slightly actually came out significant. So everything's less than 1, that's a good thing, but not significantly different from 1, just uniformly across the board. So we're not seeing much in the way of acts being differential between positive and negative partners. And the last one is protection. So what should be happening here is that there should be lower risk and more protection, particularly with the HIV negative partners, this is 3, which I don't have a key. No, I need a key badly. Blue is negative, and we're seeing, and I think the don't enter sign is the unprotected. So we're seeing them move into the more into the red and away out of the blue. So that's less risk. And now this one, in contrast with the AX one, is actually everything's coming out significant. So baseline group, this is an odds, not an odds ratio. The rest would be odds ratios, but that's coming out as people are generally safer with their HIV negative partners. This is not 100%, it's not overwhelming, but just across the board, all the groups are coming out as they're more likely to be using protection with their HIV negative partners than with their HIV positive partners, even given equal numbers of ACs. The last slide said that while it wasn't significant, they looked like they were having fewer ACs with their HIV negative partners. And then the top one was about the first one was whether there's more or fewer HIV negative partners compared to other groups. Okay. So rushing through it quickly, basically protection, yes, ACs and partners, not so much going on. So summarizing, so we define sexual behavior profile for the study participants and analyze that, and that's a fairly complicated thing. Partners and ACs within partners and distinguishing between positive and negative, protected and unprotected. Partner behavior changed over the course of the study, becoming less risky. Both groups. Behaviors certainly vary across different locations and risk groups. There's already kinds of seroadaptation going on. And sort of the greatest differences are proportion of HIV negative partners, I guess, so I didn't quite say it right just a little bit ago. Not so much with the activity. Protection is being used more, but not 100%. And so the idea would be that drilling down into the data like this is what you need in order to develop your behavioral interventions. You can target them to individuals and strengthen the areas that are going to contribute to risk or that the person is willing to accept. Okay, so last thing is just huge, ridiculous table of lots of numbers like we'd already been seeing. So let's leave that alone. Okay, so yeah, Scott.
So there's a lot of nice features about the model, but one of them in particular that seems like it applies to pretty much all our analyses, if it's sex or not, is the whole idea of regression to the mean, and we always have some strict entry criterion.
Mm-hmm.
What is, how you adjusted for that in your model? Is that something you can talk about here, or is it really complex?
You have a Poisson distribution, or maybe it's normal, whatever the distribution is. Zero's not allowed. So the likelihood actually changes because you can't have zeros. So it's basically it's called a truncated Poisson, and we actually modeled it as a truncated Poisson. And so then that estimates lambda, the mean of that Poisson, to be a little bit lower because it knows that zeros aren't allowed. And so that's, not too hard to talk about. Then one has to implement it, and I'm not sure implementation is very easy.
So probably not in SAS.
Yeah, I haven't heard about it being available much in SAS. It's sort of the opposite of a ZIP model, zero inflated Poisson model. So instead of having more zeros, we got them truncated, removed out from the data set. So Bayes analysis makes it easier to do that. Yeah.
So the entry is basically biased in
Yeah.
a way, and actually for many intervention trial,
Yes.
it's designed purposely that way, because
Right.
if you expect something decrease, you better to include
Right.
everybody who have the potential
To be decreased,
Yeah.
yes.
So in many studies, actually, we set up the age limitation. We have all the criteria. Basically, want them to have some risk behavior.
Yes,
Then we can see the reduction.
right. And so,
without that, I see.
so the reduction, some of it's attributable to the regression, this kind of regression to the mean, or the censoring of zeros in the beginning. Some of it is probably is actually happening, some of it, but then we have all our different explanations. You might want to design at least the occasional study to get at some of these different possible explanations, to see if they're the cause. Yeah. Yeah.
So I may miss this, because I'm a little bit late. Did you account for sexual role, self-assigned sexual role, in your risk calculation?
No, the risk was IDU, and then that included MSM, heterosexual females. Then if not IDU, then it's MSM, heterosexual males and females. So that's just those 4 groups. In the partner level analysis part of things, there's main partner or not as a predictor.
Top or bottom?
No, I don't think we collected a lot of information, so I'm not sure that we had, for example, receptive or not, insertive versus receptive as even any data collection, which is too bad, but they are already burdening people with quite a lot of information requests per partner, so I can understand, yeah.
Thanks, Rob, again for your talk. So, you talked a lot about plausible explanations,
Yes.
big drop from baseline, to your first follow-up.
Mm-hmm.
So have you had a chance to look at kind of ignoring the first from baseline to 3? Because across all the outcomes you see, if you kind of ignore it from 0 to 1,
Yeah.
like...
Then there's a smaller
Right,
decrease
right.
there, even leveling off.
So if you reanalyze the data without taking into account of the baseline to first follow-up
Mm-hmm.
drop,
Yeah.
do you see any, so you would, you look at the intervention of treating the first follow-up as the baseline. Have you done that?
So we included baseline, and I think if I understand you right, to do what you're asking, I would actually want to remove that entire data point,
Right.
so that baseline, just make it completely go away and now reanalyze without it, because that is going to have effects all the way through. We have this random effects model, which isn't quite as strong as the usual one, because we do have autocorrelated error, so that these things are allowed to not be what it says is that although somebody is likely to be high if they were high in the beginning, they don't have to be. While the random intercept model says if you're high one time, you're high always. If you're low one time, you're low always. So we relax that some. But still, I'd want to actually remove that and then see if perhaps there's still the trend as in significant or not, versus may still be visible in terms of decreasing, but actually, the going to...
Because I think that the challenge with big studies with assessments that take a very long
Mhm.
time, I think one of our studies actually had this case where, when you actually administer the questionnaire, you find out that there's a lot of tweaking, or, there's certain things that are not, that you didn't anticipate.
Right.
So I think one of our studies, we actually had a pre-baseline
Yes.
assessment.
Right.
And then based on that, we had to adjust the assessment accordingly.
Yes.
And then we had a baseline. And then that kind of potentially eliminated the survey conditioning
Right.
problem. And
Or another study I remember hearing about was one where there was a baseline. It wasn't even at least I didn't hear it spoken of that way, but there was a baseline, and then there was another baseline 3 months later, and that's when the intervention was randomized and decided. And that gets rid of that initial decrease or whatever, people settle into the study. I've certainly seen it in many different studies that there is this baseline effect. On one study, it was just a whole list of how many things you could be sick with, and they figured the enumerators were just real enthusiastic, and every stubbed toe became typhoid, and so there were all these huge drops from baseline to the first one, and we ended up just analyzing it. We just dropped it. But that wasn't this main, that was easy to do because we had 18 follow-ups or something in that one. So
Sort of a partial solution to the survey conditioning problem. Carl Latkin out at Johns Hopkins, he does this sometimes where if somebody says no, thinking that they're going to get out of it, you torture them with other questions that they have to go into. So it doesn't necessarily lengthen the survey that much.
Or it doesn't shorten it by saying no.
Shorten it
Yeah.
that much, yeah.
Oh.
Well, the whole assessment actually changed dramatically in the last 15 years. People don't really ask each partner anymore for
Yeah.
5 partners. That method actually,
Was-
nobody use anymore. Yeah.
So what are people using now? What's the?
Yeah.
Well, they can ask how many partners, but they mainly emphasize on the protection. Because sometimes
Mhm.
how many partners doesn't really tell you if it's risky or not.
So, well, like I know Gorbach does, she'll ask like last partner or last act.
Yeah.
She won't even ask,
Oh,
and
you
so
know,
like last 2 or 3 maybe.
actually,
at
I
most.
think go to different way. One way is to answer that, to shorten the question. Another way is to go extend to more partner,
Mhm.
focus on network analysis. That means you this way collect data, you cannot do the current network analysis even.
Yeah.
But you can
Right.
really focus on the partner in a different way rather than just ask, anonymously.
Yeah, we did try, then one of Gorbach's, we did try to get in the partners. Didn't happen.
Mm.
So you wanted, actually get them in and get them the same study and ask them about their partners. And then we would leave it there. We weren't going to keep iterating because that's one of these snowball things that don't work very well, don't give you good inference. But they couldn't even get the partners in that particular one. Yeah,
I
Dr.
actually
Bellin.
came in really late, but thanks for.
I forgot to send you the talk this morning, so you could have read it in your copious free time.
Now you-
But, so I missed the reason that you didn't include the zeros, was it a
They
two-part
sent,
rule?
they were not allowed into the study at baseline. You had to be risky.
You
Yeah.
had to have had
Had-
at least one risky section. I
Yes.
guess then the question is, would the same method be possible to include as part of a two-part model, where the first part might be an indicator
Well,
for
so there are
any
no-
risky acts or no?
So I'm simplifying the entry criterion by leaving out one half of it, which I mentioned to others, everybody here earlier. Then you had to have at least one risky act with one HIV negative partner in the last 3 months to get into the study. So therefore, there can't be any zeros. At least one of your partners, HIV negative partners, there's a 1 in there. And so we actually included that in our distributions, that it was 1 or greater, so it was a truncated Poisson. And that's, so then at follow-up though, you could have 0, and people certainly did. And so then 0's allowed, and we don't truncate at any other time, just the baseline time. And so that does bring the mean down a little bit, and it shallows out a little bit the decrease that was observed over time in numbers of partners and acts and things.
I guess another related question, what I was thinking is maybe there's a model that has a binary outcome of whether there's any risky act or no, and then among ones where there's a risky act, and so, but I think that.
Yeah, well, that's actually estimable from the output here. So if we had wanted to, with the output here, we would not need to rerun the model. We can answer that question, and whether that is different between treatment groups, or if there's a difference for MSM versus females versus heterosexual males versus females. We can actually IDUs, so we can actually answer that question without fitting something new. Now, if you ask that question in enough complication, like you start asking about covariate interactions, we didn't fit those, so I can't. That would require a new fit. But by itself, I can actually do that. And that's actually what this picture is in a sense. It's the other direction, which is summing up across all partners, all acts on the bottom side, bottom 2 plots. Yeah.
So,
Yeah. So one actually doesn't need a new
one
fit.
Final,
Mhm.
interested in your comment about this whole zero sorting and zero adaptation.
Mhm.
So what are your thoughts about looking at, were you able to look at, so first of all, I think zero sorting, in my opinion, this is all based on self-reporting, right?
Yes.
So
Yep.
based on their perception. So
Yep.
one question is, what are your thoughts about zero sorting as a strategy?
Very
And
good.
the second one is,
Ooh.
were you able to look at zero adaptation by the type of relationship they're in, whether they're engaged in a, for example, monogamous relationship versus, having sexual encounters with casual partners. So a zero adaptation might be just stagnant. For example, if you have a zero discordant couple
Mhm.
and you're positive and you're negative, but you're engaging in a protective
Protective.
behavior. That's not going to change if you're having the same partner monogamously
Mhm.
versus having
Right.
a different partner.
So, just trying to think of how, if I could fit, there's two or three versions, which is, do I have to fit another model, or can I do like with Tom's question, and is it available someplace in the output, even if I can't tell you right now? And I'm thinking that's more of a, that would kind of need to go back to this picture, the upper part, or even earlier, maybe this kind of picture. So this is separating partners up two ways, into positive and negative, and then the covariate of being a main partner actually influences the analysis down here at the act level. Now you're adding in another covariate about partner type, in a way, or even maybe person. And so that would mean splitting these folks up, the partners up, into additional categories. So I could use the same model, but it would be there would be a new analysis with something perhaps different at the partner level. So I think I could, we'd have to work out that that information's in the data to the extent you want it, and then promote it. The code is one up. It's not flexibly adapted to every situation, unfortunately. Which is unfortunate, but doing it one up is the first step, and then as people ask interesting questions, then you make it more and more flexible. So I think it fits into the question, if I understand it, fits into the general framework. It isn't the specific analysis that we did. Yeah. And so I have another not quite this complicated model that I'm trying to get published, and one of the questions was, and it's using Clear, and one of the questions from the editor was, maybe this is asking too much, but for other infectious diseases, would this kind of analysis be useful in some way or another? Which, I barely know about colds and flu, much less claim to be expert on HIV and AIDS, so I'm like, don't want to go there, but the more questions that somebody, that you guys ask about it, then the more fodder it is for the stat publications of this type. So I didn't answer you, but
No, it's
talk.
fine. Thanks.
Yeah.
Any more questions? If not, well, thank you very much.
Thanks.
for your-